Volcanic rock is a rock formed from lava erupted from a volcano. In other words, it differs from other igneous rock by being of volcanic origin. Like all rock types, the concept of volcanic rock is artificial, and in nature volcanic rocks grade into hypabyssal and metamorphic rocks and constitute an important element of some sediments and sedimentary rocks. For these reasons, in geology, volcanics and shallow hypabyssal rocks are not always treated as distinct. In the context of Precambrian shield geology, the term volcanic is often applied to what are strictly metavolcanic rocks. Volcanic rocks and sediment that form from magma erupted into the air are called volcaniclastics, and these are technically sedimentary rocks. Volcanic rocks are among the most common rock types on Earth's surface, particularly in the oceans. On land, they are very common at plate boundaries and in flood basalt provinces. It has been estimated that volcanic rocks cover about 8% of the Earth's current land surface. The subfamily of rocks that form from volcanic lava are called igneous volcanic rocks, to differentiate them from igneous rocks that form from magma below the surface, called igneous plutonic rocks. The lavas of different volcanoes, when cooled and hardened, differ much in their appearance and composition. If a rhyolite lava stream cools quickly, it can quickly freeze into a black glassy substance called obsidian. When filled with bubbles of gas, the same lava may form the spongy appearing pumice. Allowed to cool slowly, it forms a light-colored, uniformly solid rock called rhyolite. The lavas, having cooled rapidly in contact with the air or water, are mostly finely crystalline or have at least fine-grained ground mass representing that part of the viscous semi-crystalline lava flow that was still liquid at the moment of eruption. At this time they were exposed only to atmospheric pressure, and the steam and other gases, which they contained in great quantity, were free to escape. Many important modifications arise from this, the most striking being the frequent presence of numerous steam cavities, vesicular structure, often drawn out to elongated shapes subsequently filled up with minerals by infiltration, amygdaloidal structure. As crystallization was going on while the mass was still creeping forward under the surface of the Earth, the latest formed minerals, in the ground mass, are commonly arranged in subparallel winding lines that follow the direction of movement, flux ion or fluidal structure, and larger early minerals that previously crystallized may show the same arrangement. Most lavas fall considerably below their original temperatures before emitted. In their behavior, they present a close analogy to hot solutions of salts and water, which, when they approach the saturation temperature, first deposit a crop of large, well-formed crystals, labile stage, and subsequently precipitate clouds of smaller, less perfect crystalline particles, metastable stage.